I'm going to go over free fall acceleration next. So we've covered previously the equations of motion for constant acceleration. Now we're going to discuss acceleration as far as what's happening when something is falling down due to gravity. So rather than A, we tend to use G for gravity instead, but you can substitute in G for these wherever you see A in these equations, you can substitute in a G instead. Uh, Acceleration is independent of the object's characteristics of mass, density, or shape, so it's the same for all objects. All objects accelerate at the exact same rate um, when they're in a vacuum. So if something is falling like a feather versus an apple, just in everyday life, of course the apple's going to fall and hit the ground first um, because of the air resistance that's preventing the feather from hitting the ground. But if it were in a vacuum and there was no air at all, they would both fall and hit the ground at the same time. The directions of motion are along the vertical y-axis. So when we're talking about free fall, something is going up and down. That is the y-axis. The free fall acceleration is negative, so we write it as negative g. And I think sometimes students get a little bit confused about when things are negative or if they're positive. Ultimately, when you get a final answer, decide if it makes sense. Decide, are we talking about something that's falling down, or are we talking about something that is just accelerating? Um, and and don't worry too much about the positive or the negative sign at the end, but I do want you to think a little bit about what's happening. Is something accelerating downward, or is it going in the upward direction? All right, so here's an example of something that's ascending, going up, and descending, going down. So in this figure, a pitcher tosses a baseball up along the y-axis, and the initial speed or velocity is 12 meters per second. And we want to find how long that it takes to reach the maximum height. So we have this given information. The initial velocity is 12 meters per second. Um, and we can use our equations of motion to figure out these different values. This says how long does it take, so that means we want to find the time. And we want to find how long it's going to take until it gets to the maximum height. So our velocity equals our initial velocity plus acceleration times time. Uh, our initial velocity is 12. Our acceleration, even though this is going upward, acceleration is still negative g. Now let's take a look at that a little bit more in this slide here. So acceleration in free fall is negative g because something is going down. And so A equals negative g, which equals negative 9.8 meters per second squared. G itself alone equals 9.8. So don't write negative 9.8 for G. We're just going to write G is 9.8, and we're going to write negative G when we're talking about downward acceleration. Some of these examples, I might not have written negative G. So that's kind of why I was saying don't worry too much about the sign of it. Just try and make sense of what is the acceleration doing. But anyway, we're trying to find how long the ball takes to get to the maximum height. So we're going to use this first equation, plug in 12 for the initial velocity, and we can write plus negative gt or minus gt. And our velocity, when it reaches its highest point, is 0. So 0 is, it's not moving. It's just sitting there at its very highest point. And the initial velocity is still 12. and we have minus GT. Now G is 9.8, and this is why I said to be careful with the negatives, just because now we have minus G. G is a positive value. It's 9.8, but we're doing minus 9.8. So 12 meters per second minus 9.8 meters per second squared. Now be careful not to combine these two. These are different values. This is acceleration and this is velocity. You cannot add these together or subtract them. So we're going to minus 12 on both sides. We get negative 12 meters per second equals negative 9.8 meters per second squared times time. And we're going to divide by 9.8 meters per second squared, negative 9.8 meters per second squared on both sides. And we get a time of 1.22 seconds. So that's how long it takes for this ball to reach the very top when it's moving at 12 meters per second. The ball's maximum height above its release point. So we want to find what is the ball's height that it gets to. So how far does it go? We found how much time that it takes to get there, but now we want to know how far up did that ball actually go into the air. So we need to use the displacement equations next. And here's our list of equations. Actually, I think maybe my video might be in the way. Let me move that so everyone can see those. But here's our list of equations here. Hopefully it'll let me paste it rather easily. Let me see here. And all right, so here are the equations for motion. And those were in the very beginning of our lesson as well. So we have to decide which equation to use for height. We're going to use displacement. So we already used our velocity equation here to find out the time. Now we're going to use displacement, the displacement equation to figure out the final displacement, or what x is for how high that it goes. So instead of using x, we're going to use y, because it's not moving left and right. It's moving up and down. But it's the same essential equation. So y minus y naught is equal to initial velocity, or I should say final position minus the initial position, is equal to the initial velocity times time plus 1/2 times acceleration times the time squared. So our initial displacement is 0. Y equals 0 at the very beginning. And the initial velocity is 12. We know our total time is 1.22 seconds. And for A, we're going to plug in negative G. And this is where it's important to make sure you're doing a negative G here, because if you do a positive, you won't quite get the right answer. So if you're ever having trouble determining what to write there, just remember that it's going down it's going down 9.8 meters per second squared. So we're going to talk about gravity as negative 9.8. But we're adding acceleration in the downward direction. You can think of it like that. So we're accelerating down. So it's negative 9.8. And then the time, we're just squaring the time, 1.22 squared. So y equals 12 times 1.22 gives us 14.64. And then plus 1/2 times all of this over here. You just plug that in the calculator. We should get negative 7.293. Add those together, and we get about 7.35 meters for the total height, or the total displacement that it's gone from the starting amount to its final height. All right. So before we found out, or now we want to figure out how long does it take the ball to reach 5 meters above the release point. So here we found out is this is 7.35 meters up here, but we want to figure out how long does it take to get to 5 meters? 5 meters is maybe about there. So we're going to set this height, or another way to say it is our displacement, our change in displacement is equal to 5. So we're going to use that same formula as before. Remember, A is negative g, and we're going to write our displacement is equal to 5 here. So we're going to plug in 5. Our initial velocity is 12 times time plus 1/2 times. Now, g is 9.8, but we're doing negative g, so it's negative 9.8 times t squared. Now we're going to write a quadratic for this. And so when we write a quadratic, we set everything equal to 0. And so now we have this quadratic, and we're going to apply the quadratic formula. B is negative 12, so minus B is positive 12, plus or minus the square root of B squared. B squared is negative 12 squared, minus 4AC. 4 times A is 4.9, C is 5. All divided by 2A, and A is 4.9. Okay, now we have plus 12, or 12, plus or minus the square root of negative 12 squared is 144. Negative 4 times 4.9 times 5 gives us 98, negative 98. So we're doing 144 minus 98. The bottom's just 9.8. And now we're going to take the square root of 46. 12 plus or minus square root of 46 gives us approximately 12 plus or minus 6.78. And then we have two answers. So we have 12 plus 6.78 and 12 minus 6.78. And that gives us 18.78 over 9.8 and 5.21 over 9.8. And so the time that it is when it reaches 5 meters is these two times. Now, you might have been thinking that that doesn't make sense because we just want to know 5 meters above from where it was thrown. But it reaches 5 meters at two different places. It's a little difficult to see, but it is a parabola. It's going up and then it's curving back down. So it's the shape of a parabola, and that means that it's going to intersect at 5 meters twice. So the first time it's thrown up is going to be 0.53 seconds, and then as it returns back is 1.91 seconds. So that's why we have those two different times for that. So one of them is on the way up and one of them is on the way down. All right, and this is the workbook assignment associated with free fall acceleration.